we have the primitive of x plus 2 divided by x minus 1, x minus 2 dx. Okay. Now, according to what we know, these are simple roots, so this is easy. This is going to be a divided by x plus b divided by x minus 1 plus c divided by x minus 2. Just like that. Okay. And we know that a times x minus 1, x minus 2 plus b times x minus 2 plus c times x minus 1, all of that has to be equal to x plus 2, right? And so this is one of those in which if we have three different roots, right, solving this system is just as easy as giving the values of the roots to this equation. You will see how everything cancels except the one that's not multiplied by 0. Okay, so here x equals 0, this simplifies to get minus 1 times minus 2, 2a equals 2, so a is 2. If x is equal to 1, this goes out, and you have 1 times minus 1 minus b is 3. So 3, b is minus 3. And then if x is equal to 2, this guy and this guy go away. So you have 2 times 1, 2c equals 4. So c equals 2. Okay, so here you have, let me see. You have 2. Is it, sorry, 2a equals 2 is not a equals 2, a equals 1. Okay, a equals 1. Then you have minus 3 here, and then you have 2. Okay. And then now these primitives are easy because all of them will be the logarithm. This is the logarithm of the absolute value of x. This is minus 3 times the logarithm of the absolute value of x minus 1. And then you have plus 2 times the logarithm of the absolute value of x plus 2, minus 2 plus the constant. Okay? Okay, now primitive of 5x squared minus x plus 3 divided by x times x squared plus 1 dx. Okay, so now first of all, well, the degree, you can see that this is degree 2, this is degree 3. Okay, so that's okay. But now we know that this is going to be a divided by x, right? And x squared plus 1 is one of those factors that you can't simplify, right? So this is going to be bx plus c divided by x squared plus 1, right? And well, so now in order to get a and bx, so you have ax squared plus 1 plus bx squared plus cx equals 5x squared minus x plus 3, right? So now you have x equals 0, this guy and this guy go out, this is a equals 3, okay? And now we have, let's see, x equals 1, for instance. So we have 2a, or in other words, 6 plus b plus c equals 5 minus 1, 4 plus c, 7, or in other words, b plus c equals 1. And then you have, if x is equal to minus 1, for instance, you still have 6 here plus b minus c equals 5 plus 1, 6 plus 3, 9, or in other words, b minus c equals 3. Okay, so if you sum these two, right, you have 2b equals 4, b equals 2, and you subtract them, you have 2c equals minus 2, or equals c equals minus 1. Okay, so now let me substitute here. And so this is 3 over x, and then you have 2x minus 1. Okay. Now this is the interesting part. Okay. Now the primitive of this, we've seen it's easy. This is 3 times the logarithm of x, right? And then, but what happens with this, right? Now this has two parts. The first one is the primitive of 2x divided by 2x plus 1, right? So as you can see, this the derivative of this is here, so this is one of those in which you have g and g prime in the numerators. This is going to be the logarithm of x squared plus 1. Okay, and so you can say this is the absolute value, you can write the parentheses because this is always positive, right? Now what happens with this? Okay, this is just the arctangent, okay? The arctangent of x plus c, okay? So whenever you have one of those non-simplifiable fractions, right? Just like this with the square part in the denominator, you're always going to get a logarithm and the arctangent, okay?